Okay, so in this part of our class, we're going to discuss how can we represent the data in form of the table, okay, and also in form of the picture. So graphical and tabular descriptive techniques, okay. So remember in the previous lecture for chapter 1, we discussed that statistics has two parts, unequal parts. One of them is called descriptive, right? And another is inferential. Inferential is more difficult, more complex, and that is going to be the focus of this class, right? But that still doesn't mean that we have to forget about descriptive, right? So we're going to start with descriptive. And a lot of what we're going to do in this chapter, and the next one actually, is what you know already. So it's going to be a review, all right? So in this chapter, we're going to look at how we can put a picture on the data and also summarize it in form of the table. All right, but before we do that, whatever we're going to discuss, okay, in this chapter equally applies to populations or samples. So it doesn't really matter if we have the entire data set, the population, or just a smaller portion, a sample, okay? What we're going to do is equally applicable to either way. So we don't care from that standpoint, right? This is the data set. That's the numbers that you have, or maybe something else, not necessarily numbers. That's all we have. Let's put a picture in it. Whatever it is. It can be the entire thing, the population, or it can be just sample. Doesn't matter. These techniques equally applicable, okay? All right, but before we start, let's kind of discuss obvious things, variables, right? What's a variable? Variable means something varies, right? So there is something that is changing, okay? That's what statistics is dealing with, random statistical variables. For example, scores, okay? Course scores. At the end of the semester, for each student, when I have all the grades entered into the system, I compute the final score, right? So it's all based on your exam 1, exam 2, final exam, homework, quizzes, project, etc., right? So I have a bunch of grades entered in the system. Then I apply percentages that I outline in syllabus, and then I come up with a final course score, and that score translates into A minus, B plus, etc., right? So final score that every student gets, I can't predict that, right? At the end of the semester, whatever computations give me, that's the final score. I can't predict that score. You can't predict that score, right? You can try to make it as high as possible, but what exactly numerically is going to be unpredictable, right? The only thing that we know is going to be a number between 0 and 100, right? So all the possible values between 0 and 100 are exactly that, values. These are different possibilities that the variable can be, okay? Specific values observed in the class are data, okay? So the entire population of all students who took BUSN 231 over the course of history of CNU is the population, right? So at the end of this semester, I'm going to give grades to just 7 of you, right? So we're going to observe 7 specific data values, okay? So data is values of the variable that we actually observe. Same thing applies to, for example, heights, right? People height. How high is the person? What's the smallest person? What do you think is the smallest height of the person can be? I have no idea, to be honest. Probably, I don't know, 3 feet, right? 3 feet tall, something like that. What's the highest that the person can be? 7? Is there anybody higher than 7? 7 feet tall? Probably not, right? So anything in between is a possibility, really, right? So if we take this class, 7 people plus myself, number 8, okay? If we measure our heights, then we're going to end up with some 8 specific values, right? Out of a lot of different possibilities. So data are observed values of a random variable. And the person's height is a random variable, really, right? It's a combination of your genetics, nutrition, lifestyle, things like that, right? So eventually you stabilize at certain height, and that's it, right? It's determined by random factors, genetics and some other random factors, okay? All right. Okay. Single data point is called also datum. Okay, so data is a plural actually, right? So when you say data, you need to say data are. Data is a plural, okay? But one data point in the data set is called datum, one single data point. All right, so this slide is actually very important. If you go back to the slide that, I believe I closed that. Okay, well anyhow, later on we're going to go back to the analysis flowchart slide, and you will see that. Remember, when we looked at the analysis flowchart, we started, like, every decision tree was starting with this black square. What do you want to do? You want to describe one population, compare two or more, or analyze relationships. If you look at this slide, analysis flowchart, the next level in the decision tree was always, what data do you have? What data type do you have, all right? So that part is important because that is the first step, how you determine which test is appropriate, okay, for your specific data and for your specific problem, okay? So all data that statistics is dealing with fall into three categories. Well, technically it's two categories and one then later is split into two subcategories. So let's discuss them. Type number one, sometimes called interval, sometimes it's called numerical, sometimes it's called quantitative, from the word quantity, in other words, count and measure, right? SPSS calls that data type scale, all right? So these are just different names for the same data type. So what is the typical interval data? Something that can be measured, all right? For example, people's height, right? People's height can be measured in terms of inches, right? Every person, we can measure the person's height in terms of inches, person's weight in terms of the pounds, right? How much money the person is making in terms of dollars and cents, right? So something that is measurable using some standard set of measures. We can use seconds to measure time, right? Let's pretend it's not happening. We can use seconds or minutes, right, in order to measure time. We can use pounds in order to measure weight. We can use inches in order to measure height, etc., right? So anything that we can measure somehow is an interval or numerical or quantitative data type, okay? So like I said again, SPSS has a slightly different name. It's called scale, okay? Another big group of data is categorical data, okay? Also called qualitative as opposed to quantitative. Okay, so categorical sounds like it has categories, right? Bunch of categories. So this data is not numerical, all right? So let's take a look at the examples. Now this one we discussed already, right? Interval. Interval data, real numbers. So height of people, weight of people, amount of money that people are making, how long does it take you to get to work from home in terms of minutes. All of that is measurable in terms of numbers, right? This is a highly privileged data type, okay? Why? Because we can perform all kinds of computations on this data. For example, if we collect people's salaries, we can compute average, right? We can compute what's the difference between the highest salary and the lowest salary. Sometimes it's called range, right? Difference between highest minus lowest, okay? We can compute standard deviation. This is a little bit harder to interpret. We're going to discuss that later, okay? How to interpret standard deviation, numerical. Okay, we can compute percentiles, okay? We'll discuss that also later. So, on the interval data, you can do practically all kinds of computations. This is a highly privileged data type, okay? So, I told you that another type is quantitative data or categorical, right? Well, categorical data has two flavors. This is the most underprivileged data, called nominal, okay? So nominal data just represents different categories. Okay, so for example, if we go outside on the street and start asking people what's your marital status, probably we're going to end up with a bunch of responses out of these four, right? People can be single, or can be married, or can be divorced, or can be widowed. Is there anything else out of these four, besides these four? Probably that's it, right? That's the list of possibilities, okay? So I go on the street and meet the first person. I say, well, Do you mind telling me what's your marital status? He says, I'm married. So I record in my file married, okay? Next person I am asking, what's your marital status? So they say single. I record single. Next person is single. Next person is married. Next person is divorced, right? So I end up with a bunch of words, really, right? Divorced, married, single, or widowed, okay? But statisticians, what they like to do is they don't like to deal with words, okay? So they like to put labels with words, okay? So therefore, typically what's done, and SPSS does the same thing actually, we can assign numbers to these words, okay? SPSS calls these numbers values. So we can numerically kind of assign a number to every single category. And these categories, there are 4 categories in our example, right? Single, married, divorced, and widowed, okay? So how do we assign numbers to the categories? It's pretty much up to us, right? A lot of people, when you ask them how do you assign categories, they start with 1 and they go with increment of 1, right? So single is 1, married is 2, divorced is 3, widowed is 4, okay? Can it be a different set of numbers? Of course, right? So we can say single is 10, married is 20, divorced is 30, widowed is 40. Just as good of the assignment as the one before, right? Or we can go completely bananas, right? We can say, single is minus 10, married is 25.6, divorced is 117, and widowed is square root from 3, right? It's weird, it's awkward, right? But the way how we assign the numbers is completely up to us, okay? Now, because this is random, because it's our choice how to assign numbers, that pretty much makes all computations invalid, okay? So for example, let's say I marry 2 people, I meet 2 people on the street, right? One is married, another is divorced. So I record 2 and 3. Let's say I compute the average. Can I compute the average? I can try, right? So married is 2, divorced is 3. What's the average between 2 and 3? 2.5, right? 2.5 is not one of my categories, right? So how do I interpret 2.5? That means that on average, people that I met are married but halfway towards the divorce. Is that the deal? 2.5? Halfway between the divorce and married? No, I can't interpret like this, right? It's just outside of my numbers, right? So therefore, whatever I do, whatever numbers I assign, very important thing, okay, to remember. If you have a nominal data, you can't compute the mean. The mean is meaningless, okay? As funny as it sounds, no pun intended. Mean is meaningless, okay? So with nominal data, there is no such thing as mean. We cannot compute the mean, okay? And that's what makes the categorical data, nominal specifically, very underprivileged, okay? All computations, or almost all computations that are allowed on interval data, numerical data, are disallowed on the nominal data. That's what makes it kind of, younger brother, so to speak, right, of the interval data. It's highly underprivileged. Almost no computations are allowed. Ordinal data. Ordinal data is very similar to nominal data. In what sense? It's also categorical. It's just a bunch of categories, okay? So therefore, again, we cannot really compute the average, or anything else for that matter, okay? One important distinction between nominal and ordinal data is in nominal data, like in our previous example, the categories are not ordered in any way, right? Is it better to be single or married? Who knows, right? Some people would like to get married, some people would like to stay single, there is no natural ordering, right, in between the categories. Ordinal data has natural order. For example, a lot of times, especially if it applies in the marketing area, right? Marketing people are all about customer experience, right? So oftentimes when they ask customer experience, they have a ranking system, such as like this one, right? Like for example, rank your customer experience, like when you check out of the hotel room, they sometimes want you to fill out one of these cards, right? Tell us how did we do, okay? Like what was your overall quality of experience staying with us, right? On a scale from 1 to 5. 1 being poor, 2 being okay, fair, 3 being good, 4 very good, and 5 excellent. These are also categories, right? These are not numbers, really. We can assign numbers, 1, 2, 3, 4, 5 to them, but it's just going to be as good of the assignment as 10, 20, 30, 40, 50, right? Not much difference, because after all, these are numbers, not numbers. These are words, right? Excellent, good, etc. These are words. But what's the difference between the ordinal data and the nominal data? In nominal, there is no ordering. Okay? One category is not better than the other. In ordinal data, there is a natural order. That's why it's called ordinal data. The categories are ordered. For example, poor is the worst one, right? That's the bottom of the line, right? Excellent is the top of the line. It's better than anything else, okay? Poor is worse than fair, okay? Good is better than fair, okay? Very good is better than good, and excellent is better than very good. So there is a natural ordering between them, okay? So therefore, it's very important when we assign numbers to these categories, whatever assignment we decide to make, we need to keep the same order, okay? So we can assign 1, 2, 3, 4, 5, they're ordered, just like poor, fair, good, very good, excellent. Or we can assign 10, 20, 30, 40, 50. It's going to be the same order, right? So numbers should reflect the order of the categories, from the worst to the best, okay? That's what makes the ordinal data different from nominal data. It's also categories, but now they can be positioned from the worst to the best, okay, in certain order, right? Other than that, it's very similar to the nominal data. So again, we cannot compute the mean, we can't compute the standard deviation, nothing, okay? Practically nothing. So the only thing that we can compute with the ordinal data is something that's called median. We're going to talk about that later, right? So, calculations. Interval data is very highly privileged, right? Just like we discussed. Practically any type of meaningful computation that you can imagine is permissible, allowed on the interval data, okay? Scale, that's how SPSS called it, scale data, okay? Nominal data, on the other end of spectrum, very underprivileged, right? No computations are allowed. Mean does make sense, it's meaningless, right? Standard deviation does make sense. We can't even compute the range, to be honest with you, because, say for example, let's go back to this slide with married, divorced, and widowed, right? So let's say, for example, I have collected a bunch of responses, okay, on the street. Single, married, and then I had another married, and I have single, and then divorced, and then single, and then married again. So I record them in the file, 1, 2, 2, 1, 2, 3, etc., right? So my highest number was 3, my lowest number was 1, right? So if I can compute the range as the difference between highest number 3 and lowest number 1, difference is 2, right? What does that mean? That difference is like my highest observation is larger than my lowest observation by 2, which is like married. But I don't know how to interpret that. It doesn't make much sense, okay? So therefore, computations on the nominal data are not allowed, okay? Technically, you can do them. Software will do it for you. Software doesn't care, it's just a program, okay? It will do for you what you ask to do, okay? But if you compute the average for the nominal data, you can't really interpret that. Plus, if you change the scale, if instead of 1, 2, 3, 4, 5, you assign 10, 20, 30, 40, 50, all of your computations shift immediately, right? Your average shift, your ranges shift, your standard deviations change, right? You didn't do much to the data, you just relabel the categories, but your computations all of a sudden are all different, right? So therefore, again, very important thing to remember, for nominal data, you are not allowed to do any computations that go with interval data, okay? Very underprivileged. The only thing that we can do with nominal data is count how many responses do we have in category number 1, category number 2, category number 3, and maybe compute percentages of these responses, okay? So what is the percentage of people who said that they're single? What is the percentage of people who said that they're married, etc., okay? That's the only thing that can be done with nominal data. Now, for ordinal data, things are a little bit better, okay? Because it's very similar to nominal data, right? We discussed that kind of by the spirit of it, right? It's still same thing. It's actually categories, right? Still, we cannot compute any averages, any measures of variability, such as standard deviation, range. None of that can be computed. But we can do one thing pretty much, okay? We can compute percentiles, or oftentimes what's useful actually in statistics, something that's called median. What's a median? Median is observation in the middle, okay? So let me illustrate that. Look at that, I have it. Oh my God, hold on. Take some skill to switch between the programs, right? And this. I just wanted to show you, yeah, this one. Very cool. All right, so let me give you an example. Some of you live on campus, some of you don't live on campus, right? Okay, that's bad, but everybody parks on campus, right? Okay, so let's say I'm a marketing guy for CNU, right? And I want to poll the opinion of students. What do you think about parking condition on campus? Okay, so here is the scale, how I'm going to do it. 1 means poor, again, poor, okay? 2 means, whoops, poor. 2 means fair. Okay, 3 is okay. 4 is good. And 5 equals excellent. All right, cool. So let's start with Nick. Nick, what do you think? Parking on campus? Fair. So that's a 2, okay. All right, Jenny? 3, okay. That's cool. Amanda, right? Yeah. You give it a 3, all right. Logan, right? 3, okay. Darius? 3, all right. Caitlin? 2, all right. And Janine, right? 3, okay. 3. All right. You guys are nice. Sometimes when I run this in class, some people say 1. Rarely I have a 4, but never a 5, I got to admit. All right, so therefore, I can now arrange them from highest to lowest, or vice versa, from lowest to highest, right? So 2 and 2, I'm going to write down 2 and 2, and the rest of them are 3, right? So I have 5 of them. 3, 3, 3, 3, and 3. So this is our data arranged from lowest to highest. This is ordinal data, right? From lowest to highest. So there are 7 data points, right? 7 data points altogether. So data point in the position number 4 separates 50% of the data below that number from 50% of the data above that number, okay? Because I have 3 numbers below and 3 numbers above. So that measure, 3, is called median. Okay, median. It's an observation in the middle, right? Separates 50% of data lower than that from 50%, half of the data higher than that. That's the only extra thing that we can compute for ordinal data compared to the nominal data. Other than that, nominal data and ordinal data are very similar. They're just categories, just like in this example. Poor, fair, good, excellent, and okay, right? So again, just like with nominal data, we can compute percentages, right? What percentage of people said 1? In our case, 0, right? What percentage of people said 2? Well, that's 2 out of 7, whatever that percentage is, right? What percent of people said 3? Okay, well, that's 5 out of 7, right? Nobody 0% said good, and nobody 0% said excellent, right? So we can compute percentage of responses in each category, and what's the observation in the middle, or otherwise known as median. That's the only 2 things that we can compute about ordinal data, okay? Other than that, it's very similar to the nominal data and very dissimilar from interval data. We cannot compute the mean, we can't compute standard deviation, none of that stuff, okay? Make sense? All right, very good. So let's go back to the PowerPoints. Okay. All right, there it is. Okay, so hierarchy of the data. Arrow pointing down. Interval is the most privileged data type, right? We can pretty much do anything that we want with this data type, right? Nominal data, least privileged. The only thing that you can do is count how many responses you have in each category and calculate the percentages of these responses, right? Ordinal data, now kind of in the middle, but it's actually closer to the nominal data, right? because still no computations are allowed. The only extra thing that you can do with ordinal data compared to the nominal data is compute the median, and that's it, nothing else. Okay, so let's run an exercise, quick exercise, right? Residents of condominium recently were surveyed and asked a series of questions. So for each type of question, let's identify what kind of information, what type of information we collect, okay, for each question. Number one, what is your age? Our choices are interval data, nominal, or ordinal data. What do you think? When people tell me their ages, what type of data is that? Interval? Yeah, it's interval, right? Numbers, right? We measure them in terms of years. We can compute the average age, etc., right? So that's an interval data. What floor do you live on? So first floor, second floor, third floor. Choices are, again, interval, nominal, ordinal. What do you think? Probably ordinal, right? Because we can't compute the average, right? One person lives on the first floor, second person lives on the second floor, right? Average is 1.5. What does that mean, 1.5? It's like Harry Potter, right? Platform 9 3/4. You've seen Harry Potter? 9 3/4? Doesn't exist really, right? So the floor 1.5 doesn't exist. So it's clearly not an interval data, but it's ordered, right? Closer to the ground, second floor, third floor, etc., right? So that's probably ordinal, you're right. Do you own or rent? So answers are like 1, I rent, 2, I own. So what do you think? Nominal? Probably nominal. Why not ordinal? Because American dream is to own a house, right? So therefore, if you ask most people, they probably tell you that their dream is to buy a house, right? So that means that owning is definitely better than renting. True? Is it universal truth or is it not so clear-cut case? Some people like renting, right? Why? Because you don't have any hassle maintaining things, right? If your air conditioner fails, you call your landlord to fix it, right? You don't cut the grass, you don't paint the walls, right? Everything is done for you. Maintenance free, right? So it's not such clear-cut case. Probably it's a nominal data. How many square feet is your residence? What do you think? What data type is that? Darius, what do you think? Interval probably, right? Because it's a number measured in square feet, you can find average and everything else, right? Does your residence has a pool on site? Answers are 1, yes it does. 2, no it doesn't, right? So what do you think? Nominal or ordinal? Nominal probably, right? Because it's not clear-cut case if it's good to have a pool or not. Most people probably say pool is good, right? But there are people who hate pools, right? Because children are always screaming and all that stuff, right? So therefore it's nominal probably. Okay, how many roommates do you live with? What do you think? Like if I live by myself with 0 roommates, if I have 1 roommate, it's 1, 2, 3, etc., right? So what type of data is that? Now choices are interval, nominal, or ordinal, right? Caitlin, what do you think? I'm going to start calling on people because you guys are so shy. Interval, probably interval, right? Yep. What's the color of your kitchen countertop? Nominal, right? Different colors, I mean, you can't really arrange colors, right? What's the best color? Well, there is no such thing, right? How many months did you live in your current place? Interval, right? Definitely interval, because that's time, right? We can measure time in terms of months. On a scale 1 through 5, 5 being the best, rate your living experience. That is definitely ordinal, right? Last one, do you think the parking space is adequate in your condominium? So 1, yes, I do think it's adequate. 2 means no, I have problems. Nominal? Now, isn't it true that to have a good parking conditions is always better than not to have good parking conditions? So there is an order between yes and no in this case, right? It's better to have a good parking, adequate parking space, right? So that probably is ordinal, right? Okay, good. All right. Now let's actually take a break here because I believe we're at the cutoff point for the video. All right, so yep, 30 minutes right there.